Now we are going to discuss about the future value of an ordinary annuity. For discussing the future value of an ordinary annuity, let us consider a 3-year annuity. So you can see the cash flow timeline of a 3-year annuity. I have not mentioned the amount of cash flow. Let us use CF. Let us indicate the cash flow by CF. So because this is an annuity, the CF is equal for every year. Okay, so if we want to calculate the future value of the annuity, then we have to calculate the future value of all the cash flows at the end of 3-year period, because this is a 3-year annuity. So the future value must be at the end of year 3. Therefore, we have to find the future value of the first cash flow, which is this CF. Okay, future value of the first equal cash flow that should be compounded so that we get the future value at the end of year 3. So you can see between the first cash flow and the point of calculating the future value, we have 2 years. This is the first year, this is the second year. So it will be compounded for 2 years. This is why the future value formula will be applied for 2 years. Okay, so CF times 1 plus the interest rate to the power 2 in this case. Now if we think about the next cash flow, that means the cash flow in year 2, it must be compounded for 1 year. So CF times 1 plus R to the power 1. That means the future value for 1 year only. Okay, but for the last cash flow, which is already in year 3, we do not have to compound because it is already in year 3. Or in mathematically you can say we have to compound it for 0 years. Therefore the power 1 plus R to the power 0, which makes it 1. So CF times 1 is CF itself. Okay, so this is how we can actually calculate the future value of this 3-year annuity. So now if we want the total future value of the 3-year annuity, then we have to add this 3, which is shown here. Okay, so it will be CF times 1 plus R square, this one, plus CF times 1 plus R to the power 1, the second one, future value of the second cash flow, and CF times 1 plus R to the power 0, the future value of the third cash flow. So we get the expression here, but well, we can just plug in the values of CF, R, and year and get the future value of this annuity. But if it is an annuity for 30 years, or if it is an annuity for 100 years or 200 years, it is not practical to do the calculation for each individual cash flow using only the future value formula. So what now we will try to derive a formula. Okay, to derive a formula from this expression. From this expression, we will be able to derive a simple formula using mathematical manipulation. But if you do not want to know the detail of the mathematical manipulation, you can skip a bit. No problem with that. Okay, so if you know the formula itself, that will be enough. Okay, but let us see how we get the future value of ordinary annuity formula. So from here, if we look at the expression, okay, it is like a geometric progression, because you can see the power is because you can see there is a common ratio between these every two corresponding elements in the expression. So if we take the sum of the geometric series, okay, in mathematics you will see there is you can Google what is the formula for sum of geometric series. I'm not going into detail of that. Okay, so ultimately it becomes CF times 1 minus 1 plus R to the power 3 over 1 minus 1 plus R. Okay, from here you can simplify. Okay, from here you can get this 1 and 1 will cancel out, and we'll get minus R here, and with the same numerator. Okay, from here taking the negatives of both numerator and denominator. Okay, the reason why we take the negative is to make the formula good looking without negative sign. Okay, so at the denominator, so the expression becomes CF times 1 plus r to the power 3 minus 1 divided by r. Okay, so this is for the 3 year. Now if you do it for 4 years, 5 years, 95 years, okay, you will get let's say for 95 years you will get 95 here. Okay, all other things will be the same. Okay, so the formula actually because the future value of a 3-year ordinary annuity is like this. So if we do it for any number of years, let's say for n year, okay, then the future value, the expression for the future value of an n-year ordinary annuity will be like this. So future value of ordinary annuity for n year is equals to the equal cash flow times 1 plus r to the power n, that means 1 plus discount rate or interest rate, whatever you say, to the power number of years minus 1 divided by r, the discount rate. Okay, so we can use this expression as the formula for future value of ordinary annuity. So I will try to show you an example of applying this formula. Okay, so let us consider the situation where you are going to deposit $1,000 at the end of every year for 30 years in an account which promises to pay interest at 12% per year. Okay, and if you withdraw the balance only after 30 years, that means before the end of 30 years you do not withdraw from the account, okay, then how much would you be able to withdraw after the 30-year period? So if we look at this example, we can see that this 1,000 will come at the end of every year for 30 years, and our discount rate is 12%. Okay, and we are going to withdraw in future after 30 years. So before solving this kind of situation or this kind of problem, we have to draw the timeline, cash flow timeline, so that we do not make any mistake. Okay, so you can see in the cash flow timeline it is the same like before, but we have 30 years here and our cash flow is 1,000 every year. Okay, so from here we have to check whether it is an annuity or not. I have already mentioned that, but this is the process that you should follow when you solve this kind of problem. Okay, so at first you have to make sure that it is an annuity, okay, and then you have to make sure that it is an ordinary annuity, because for annuity due the formula will be a bit different, which we will discuss in another lecture. And how many years of annuity, that is another thing. Okay, so if we check, yes, it is an annuity because it has multiple cash flows, the cash flows are equal, and also cash is deposited in equal interval of time, that means every 1 year. And also it is an ordinary annuity because the first year cash flow is deposited at the end of first year, second year at the end of second year, and so on. Okay, so this is an ordinary annuity, so we can apply the formula of future value of ordinary annuity. And also if we want to apply the formula, we need to know how many years, what is the value of n. So the easiest way to find is you have to know how many equal cash flows are deposited. Okay, so you can see you will deposit 1,000 for every years of the 30-year period, so therefore your deposit will be, your cash flow will be 30 cash flows, 30 equal cash flows. So this is a 30-year annuity. Okay, so we have got all the values, like we know that the CF is 1,000, we know that the value of n is 30, okay, and we also know that the value of r is 12%, that means 0.12 in decimal form. So if we want to apply the formula, okay, we have to know the formula first. Let us look at the formula again. The future value of an n-year ordinary annuity is this one, CF times 1 plus r to the power n minus 1 divided by r. Okay, so here we just plug in the values. The cash flow is 1,000, r is 0.12, n is 30, okay, and here r is again 0.12. Okay, so the future value of the 30-year ordinary annuity of this example is simply you plug in the values and use your calculator to find, and if you do, you will find that the value is, the future value is $241,332.68. Okay, so thank you very much for attending this lecture. See you again.